Lesson: Protecting Cloud-Based AI Services. Protecting cloud-based AI services is a critical concern for organizations leveraging artificial intelligence in their operations. As AI becomes more integrated into cloud environments, ensuring the security of these services is of paramount importance. This lesson focuses on providing actionable insights, practical tools, frameworks, and step-by-step applications that professionals can directly implement to safeguard AI services deployed on cloud platforms. The first step in protecting cloud-based AI services involves understanding the unique vulnerabilities associated with AI and cloud environments. AI systems in the cloud are susceptible to a range of threats, such as data breaches, adversarial attacks, and unauthorized access. For instance, adversarial attacks, where malicious inputs are crafted to deceive AI models, pose significant risks. Research has shown that even minor perturbations in input data can lead to erroneous outputs, potentially causing severe consequences in critical applications like autonomous vehicles or healthcare diagnostics. To counter these vulnerabilities, organizations must adopt robust security frameworks. One effective approach is the use of the zero-trust architecture, which emphasizes the principle of never trusting but always verifying. ZTA requires continuous authentication and authorization of all entities accessing AI services, ensuring that only legitimate users and devices can interact with sensitive data and models. Implementing ZTA involves deploying identity and access management tools such as Okta or Microsoft Azure Active Directory, which provide secure authentication and authorization mechanisms. Encryption is another vital component in protecting cloud-based AI services. Encrypting data both at rest and in transit ensures that sensitive information remains confidential even if intercepted by malicious actors. Tools like AWS Key Management Service or Google Cloud Key Management help manage and automate encryption processes, allowing organizations to protect their data without compromising performance. Additionally, homomorphic encryption, which allows computations on encrypted data without decryption, offers a promising solution for securing AI models processing sensitive information. Monitoring and logging are crucial for detecting and responding to security incidents in cloud-based AI services. Implementing comprehensive logging solutions, such as AWS CloudTrail or Google Cloud Audit Logs, enables organizations to track access and modifications to AI resources. These logs can be analyzed using security information and event management tools like Splunk or IBM QRadar, which provide real-time threat detection and automated response capabilities. A case study involving a large financial institution highlighted how the deployment of SIEM tools reduced the time to detect and respond to security incidents by 60%, significantly mitigating potential damage. Vulnerability management is another critical aspect of securing cloud-based AI services. Regularly scanning for vulnerabilities using tools like Nessus or Qualys helps identify and remediate weaknesses in AI applications and underlying cloud infrastructure. Organizations should also implement patch management processes to ensure that all software components are up to date with the latest security patches. In 2017, the Equifax data breach demonstrated the catastrophic consequences of failing to patch known vulnerabilities, resulting in the exposure of sensitive information of approximately 147 million individuals. In addition to these technical measures, organizations must cultivate a culture of security awareness and training. Educating employees on the importance of protecting AI services and recognizing potential threats is essential for maintaining a secure environment. Security training platforms like KnowBe4 offer comprehensive programs to enhance employee awareness and preparedness against social engineering attacks and other security threats. Moreover, organizations should consider leveraging AI-based security tools to protect their cloud-based AI services. Machine learning algorithms can enhance threat detection and response capabilities by analyzing vast amounts of data to identify patterns indicative of malicious activity. For example, Darktrace's AI-driven cybersecurity platform uses unsupervised learning to detect anomalies in network behavior, enabling organizations to respond proactively to emerging threats. Finally, an incident response plan tailored to cloud-based AI services is indispensable. This plan should outline procedures for identifying, containing, and mitigating security incidents, ensuring minimal disruption to operations. Tabletop exercises, where teams simulate real-world attack scenarios, can help refine these plans and ensure that all stakeholders are prepared to respond effectively. In conclusion, protecting cloud-based AI services requires a multifaceted approach encompassing robust security frameworks, encryption, monitoring, vulnerability management, employee training, AI-based security tools, and a comprehensive incident response plan. By implementing these strategies, organizations can mitigate the unique risks associated with AI in cloud environments, safeguarding their data and models from potential threats. The integration of practical tools and frameworks, as discussed in this lesson, provides a solid foundation for enhancing the security posture of cloud-based AI services, ensuring their resilience against ever-evolving cyber threats.